So with x to the fourth minus 2x squared minus 8, we need to factor, and we're going to factor it into two parentheses. The first method asks us to introduce a new variable. It says let u equals x squared. Well, if u is equal to x squared, what does u squared equal? Well, it equals x squared squared, right? What happens when you square x squared? X to the fourth. So I'm going to replace x to the fourth with u squared. I'm going to replace x squared with u. And then I'm going to factor. I think we can factor this one. So what do you multiply together to get u squared? U and u. What do you multiply together to get negative 8? Well, your options are 1 and negative 8, negative 1 and 8, 2 and negative 4, negative 2 and 4. Which pair should we use in order to get negative 2 in the middle? Okay. So u plus 2 and u minus 4. Now let's check that to be sure we did the right thing. U times u is u squared minus 4u plus 2u minus 8. Yes, that gives me negative 2 in the middle. Okay, so we're going to set that equal to 0. No, they're just asking us to factor. We're not ready to set equal to 0 yet. So we factored that. Now I want you to go back and I want you to replace u with its value. What did we decide that u was equal to at the very beginning? X squared. So this really says x squared plus 2 times x squared minus 4. Can you factor this any further? Can you do anything else to x squared plus 2? No. Can you do anything else to x squared minus 4? Does x squared minus 4 fit the difference of squares? Yes. So we have x squared plus 2 times x plus 2 times x minus 2. Okay, any questions there? If you don't like introducing the u into the problem, you can factor this into x squared and x squared. You may find this method is easier for less confusing for you. So we factor x fourth into x squared and x squared. Then we need the factors of 6. What do you multiply together to give you 6? 1 and 6, 2 and 3. Which pair of factors should I use in order to get 7 in the middle? Okay. Plus 1 and plus 6. Now go back and look and see if you can do anything else with x squared plus 1 and x squared plus 6. Are either of those the difference of squares? To be the difference of squares, you got to be subtracting first of all. Are either of those subtracting? No. So there's nothing else I can do. Okay? Let's work on this one. X to the fourth factors into x squared and x squared. Is everybody following along with me? Is everybody taking notes? And negative 10, I need the factors of negative 10. Negative 1 and 10, 1 and negative 10, negative 2 and 5, 2 and negative 5. I need to choose the pair of factors that will give me negative 3 in the middle. Okay. So x squared plus 2 and x squared minus 5. Are either of these able to factor any further? Difference of squares is really what you're looking for. Well, this is subtraction, but is 5 a perfect square? No, so we're done with that. Now we have to solve these with degree 4. Now, if it's degree 4, how many zeros are you going to find? 4 of them. Okay? Well, before we factor this, we need everything moved to one side. So the first thing I want you to do is subtract 12 from each side. X to the 4th minus x squared minus 12 equals 0. We're paying attention? Factor. X to the 4th breaks down into x squared and x squared. Now you need the factors of negative 12. 1 and negative 12, negative 1 and 12. 2 and negative 6, negative 2 and 6. Negative 3 and 4, 3 and negative 4. Which factor pair do you need? Okay. So I have x squared plus 3 and x squared minus 4 equals 0. Will either of those break down any further? Yes, one of them is the difference of squares. The first one stays the same. The second one we factor into x plus 2 and x minus 2. Now, since this is one of those problems that says equals 0, you're actually finding the 4 spots on the graph where it makes its turns. So we need to set this each individual parenthesis equal to 0. So we'll start with x squared plus 3 equals 0, and then x plus 2 equals 0, and then x minus 2 equals 0. Subtract 3 from both sides. X squared equals negative 3. But I'm looking for x, not x squared. What is it that I can do to undo squaring? Take the square root. So I'm going to take the square root of each side. And so x is equal to, anytime you take the square root as a method of solving, be sure you enter the plus and minus because it's got a positive and negative answer. What is the answer to the square root of negative 3? I square root of 3. Where did the I come from? The negative 1. Negative 1 times 3, square root of negative 1 is I. The next one, subtract 2 from each side. X is negative 2. The next one, you add 2 to each side. X is 2. So you have 4 answers here. You have positive I square roots of 3, negative I square roots of 3, negative 2, and positive 2. Those are your 4 zeros. 4 places the graph's going to cross the x-axis. How many of them are you going to be able to see on the graph? You're going to be able to see negative 2 and positive 2. The other 2 are imaginary. They're not going to show up when we graph it on the real coordinate system. Okay? It's going to do its thing, but it's not going to touch x-axis visibly except for 2 and negative 2. Okay, let's do one more together. How do we factor this one? X to the 4th plus 11x squared plus 18 equals 0. What do you do with x to the 4th? It's x squared and x squared. And what about 18? Alright, 9 and 2. Can you do any more factoring with x squared plus 9 or x squared plus 2? They have to be the difference of squares. It has to be subtraction and it has to be a square. 9's a square, but it's not subtraction, so no, we can't do that. So we're ready to just set this equal to 0. X squared plus 9 equals 0. X squared plus 2 equals 0. Everybody paying attention? subtract 9 from each side. X squared is negative 9. Subtract 2 from each side. X squared is negative 2. How do you finish solving this with the x squared? Take the square root. So x is equal to the positive or negative. What's the square root of negative 9? 3i. Negative part yields an I, and the square root of 9 is 3. Take the square root of each side here. And the answer to the negative square root of 2 is, or square root of negative 2 is I, and the square root of 2 does not simplify. It stays where it's at. So you have 4 answers here. Your 4 answers are 3i, negative 3i, I square root of 2, and negative I square root of 2. Those imaginary roots occur when you're trying to do what? When do you get imaginary roots? When you're trying to take the square root of what? A negative number. When you try to take the square root, you always end up with a positive and a negative, right? Every time I tell you, okay, look, you're going to take the square root as a method of solving, you're going to have 2 answers. One's a positive and one's a negative. So those imaginary roots are always going to occur in pairs. One will be positive and one will be negative. 3i and negative 3i. Negative I square root and positive I square root of 2. So if I tell you that I know of a function that has 7i as one of its zeros, what else do you know has to be a zero of that? Because those things occur in pairs. Negative 7i. That's the concept that they're going to ask you about in college algebra. They're going to give you 7i, and you're going to have to know that negative 7i also is a zero because they come in pairs. Now, will you be able to see any of these zeros on the graph? No, they're all imaginary. If I graphed it on my calculator, it wouldn't touch the x-axis at all.